Okay, in this video we're going to talk about how to solve linear systems with more than two variables, okay? We're also going to talk about some row operations. The main objective of this video is to talk about how to change these systems of equations into triangular form, how to use Gaussian's elimination, how to operate in elementary row operations, which is called row echelon form, and we're going to talk about reduced row echelon form. And then finally we're going to talk about how to solve systems using inverse matrices, which should be a review from Algebra 2. Okay, the first one is going to be the Gaussian elimination. So our first example here is going to be x minus 2y plus z equals 7, 3x minus 5y plus z equals 14, and 2x minus 2y minus z equals 3. So what we're going to do is we're going to do several operations in order to get our equations down to triangular form. And then from triangular form, it's very simple just to use substitution and find your solution. Okay, so the first operation that we're going to do, and this is going to be a little bit confusing at first, but you'll get it after a minute here. Okay, we're going to take our first equation and we're going to multiply it by -3, and we're going to add this to our second equation. What this does is it eliminates our x value here in our second equation. So once we multiply our first equation by -3 and then add it to the second, we're going to replace that sum with the second equation. Okay, so I'm just going to write down my first and my second equations here, and where my first equation is multiplied by -3. So I have -3x plus 6y minus 3z equals -21. And then I'm just going to write my second equation down below, which is 3x minus 5y plus z equals 14. Okay, we add these two together straight down when we're looking at y minus 2z equals -7. Okay, so this sum here is going to replace our second equation in our system. So I'm just going to rewrite it out here to the right. X minus 2y plus z equals 7. Our second equation now becomes y minus 2z equals -7, and our third equation stays the same. Okay. Now our next step is we want to try to get rid of the x in our third equation there. So what we're going to do is we're going to multiply our first equation by -2, since our third equation here has a +2 in front of the x, and we're going to add it to our third equation and replace the third equation. Okay? So what I'm going to do here on the left is I'm going to multiply my first equation by -2. That's going to give us -2x plus 4y minus 2z equals -14, and then I'm going to write my third equation below it, which is 2x minus 2y minus z equals 3. When we add these together, we're going to get 2y minus 3z equals -11. Okay, to the right here I'm just going to write what we have left over right now. We have our first equation stays the same. Our second equation from what we did in the previous step is y minus 2z equals -7. And then we're going to replace our third equation here with our sum that we just got. So that's 2y minus 3z equals -11. Okay? All right, now we have one more step, and what we're going to do is we want to get rid of the y in our third equation here. So in order to do that, we're going to use our second equation. We're going to multiply it by -2 and add it to our third equation. Okay, so just using what I have left over here, I'm going to take my second equation and multiply by -2. So it's -2y plus 4z equals 14. And then my second equation stays the same, 2y minus 3z equals -11. Adding straight down, we're going to get z equals 3. Okay? Now, what this produces here at the end is we have x minus 2y plus z equals 7. y minus 2z equals negative 7, and z equals 3. Okay? This here is called the triangular form. Okay, the triangular form is good because you know what your z value is. You can substitute your z value into the second equation and find y, and substitute your y and your z into your first equation and find x. Okay, when you do that, you are going to get a solution for this problem, and your solution should be 2, -1, 3. Okay, so your x value is 2, your y value is -1, and your z value is 3. Make sure you try this and see if you get the same solution. Okay? Okay, the next thing that we're going to talk about are your row operations in your row echelon form. Okay, what we're going to do in order to show you row echelon form is I'm going to actually use our previous example to help us do this. Okay, this is our previous example written out in as a system of equations. We can rewrite that using augmented matrices. Okay, an augmented matrice is just the coefficients of each term here written as a matrice. Okay, so these are like our x values, these are our y values, these are z values. And then like our equal sign would be here, and this is our solutions for each one. Okay? It's very important that you keep it organized and in this order when you're using these matrices. Okay? So if we go through the previous step, we can rewrite our value in row echelon form. And basically what that is the triangular form of our matrix or of our system here. Okay? So if we look at our first step from our previous one, and I'm going to try to have this right here beside it. So our system of equation, this is what we started with here. And so written as an augmented matrice, it looks like this. Okay, to get to our second step, what we did was we multiplied basically row 1 by -3 and added it to our second one. So when we did that, we had this system of equation, x minus 2y plus z equals 7, y minus 2z equals -7, and then our third equation was the same. Okay, so that is just our first step that I got right here from the previous page. Okay, if I wanted to write that as an augmented matrice, what we would get here is going to be 1, -2, 1, 7, 0, 1, -2, -7. Remember, if there's nothing there, we have to have a placeholder of 0. And then 2, -2, -1, 3. So that's kind of like our first step from our Gaussian elimination method, and then this would be our matrix method. Okay? Our second step, what we did was we multiplied our first equation by -2 and then added it to our third, and then replaced our third. So essentially that would be like multiplying our first row by -2 and adding it to our third row. So after we did that, just looking at our previous example here, we had x minus 2y plus z equals 7, y minus 2z equals -7, and 2y minus 3z equals -11. Okay? To write that as our augmented matrice, we just have 1, -2, 1, 7, 0, 1, -2, -7, and 0, 2, -3, -11. Okay? And then we can do the same thing with our third step here. In our third step, we basically put it into triangular form, and we're able to multiply our second equation by -2 and then add it to the third. So when we did that, we ended up with x minus 2y plus z equals 7, y minus 2z equals -7, and z equals 3. Okay, augmented form, that's going to look like this. Okay, now this here, this matrix C at the end here, corresponds to our triangular form in our previous example. Okay, so these two correspond to each other. Now, this is also what is called row echelon form. Okay, so anytime you get it down to here, this is called row echelon form. Okay, now this next page here, I want to just give you a definition of what row echelon form actually means. Okay, so our definition is a matrix that satisfies the following. The rows consisting entirely of zeros, if any, are at the bottom. Okay. The first entry, if any row with non-zero entries, is 1. So if you take a second and just look at what we wrote down in our previous example, our first entries, let it focus for a second. Our first entries are 1 unless they're 0. So notice there's no values here, 0, 0, 1. We have 0, 1. We have to start with a 1. Okay? So your first entry has to be 1 or 0, basically, and they go down in order. And that's kind of what this last step here says. It's leading ones move to the right as we move down the rows. Okay, your book words it a little bit differently, which is a little confusing. So you're just looking for, like, we start with a 1 here. The next row, we move the 1 to the right, just one space, so it's 0, 1. The next row, we have 0, 0, 1. So that's kind of what you're looking for. If there were 4 variables, you'd have a fourth row, it'd be 0, 0, 0, 1. Okay? And so on. All right, in this next example, we're going to talk about finding row echelon form. So to find row echelon form, you're going to be given something like this, where it's an example, and the first step is to write your augmented matrix. Okay, so we're going to start, and we're just going to write that out. Okay, so this is our augmented matrix, and what we want to do is we want to put it in row echelon form. Okay, so basically we need to make this 2 a 0. Okay, so what we're going to do is we're going to multiply row 1 by -2, and we're going to add it to row 2, and basically replace row 2 with that sum. So row 1 stays exactly the same. Okay, now I'm going to multiply row 1 by -2 and then add it. So we get 0, 3, -5, and 6. Okay, the third row is going to stay exactly the same. 2. All right, now our next step, we want to make sure that this down here is also a 0. So in this case, all we have to do, see how it's a +1 here and a -1 here, is we just have to add row 1 to row 3. Okay, so we're just going to add row 1 to row 3. And what ends up happening is we get the first 2 rows stay the same. And then our last row becomes 0, 1, -1, and 4. Okay. Now, this is a really good example here because if you take a second and look at your third row, your first term, or sorry, not first term, your second term in your third row is a 1. We technically want that to be in our second row. So what we can do here is we can just switch rows 2 and 3. So we're just going to literally just switch those 2 rows together. So our first row stays the same. Let me make sure I didn't make any mistakes. 0, 1, -1. Okay, good. So once you have switched those 2 rows, now we need to get rid of this 3 that's down here in the third row. So what we're going to do is we're going to multiply the second row by negative 3 and add it to row 3. Okay? So when we do that, we're looking at 1, negative 1. Top row stays the same. Second row stays the same. And then our third row, we're multiplying the second row by negative 3 and adding it. So we get 0, 0, negative 2, and negative 6. Okay? Now, looking at our new matrix here, everything looks good in the first two rows, but our third row has this negative 2 as its first term. Okay? We need that first term to be a 1, remember? So what we're going to do is we're going to multiply row 3 by a negative 1/2. Okay? When we do that, oops, I'm sorry. We should get a 1 here, because negative 1/2 times 2 is going to give us 1, and then we should get a 3 here. So once we're at that step, we have our matrix in row echelon form, okay? Because our leading terms are going to be 1 going down in this diagonal here. All these other leading terms are 0, okay? So this here would be our answer. Okay? All right, so that's row echelon form. The next thing we're going to talk about is called reduced row echelon form. And reduced row echelon form is really nice because when you have reduced row echelon form, you can just look at the matrix and tell what your answer is going to be. So essentially, what you can do is you can take your row echelon form and reduce it even more so that you have your 1 in your we'll just go through the example and it'll make sense at the end. Okay, so if we take our answer from our previous problem, okay, so our row echelon form was 1, negative 1, 2, negative 3, 0, 1, negative 1, 4, 0, 0, 1, 3. Okay, so remember, this is our row echelon form from our previous example. Okay? What we want to do is essentially in the first row make these 1s, so we have our first term equals negative 3. Here we want to make this term a 0, I'm sorry, we want these to be zeros. This term here to be a 0, so we have 1 and 4, or whatever this value will be. It's going to change. And then here, this one is already good because we have 1 and 3 here. Okay? So, what we can do is we just have to do more operations here to make those 0, okay? So what we can do is, let's first focus on this term here. I want this to be a 0. So I can add row 2 to row 1, and that's going to make that a 0. So I can take row 2 plus row 1, and when we do that, we get 1, 0, 1, 1. Second row stays the same. Okay, so now we're a little bit closer on our way. Now we want to make this 1 here in the first row a 0 as well. So if you notice in what we can do is we can go ahead and add, and you could do this a couple different ways, but what I did was I went ahead and took negative 1 times our row 3 and added that to row 1. Okay? So what we get is 1, 0, 0, negative 2. And then our second row, 0, 1, negative 1, 4. And then 0, 0, 1, 3. Okay, so our row 1 is good. Our row 3 is good. Now we just need to get rid of this value here to make our row 2 good. Okay, so when we do that, we're going to take row 3 and add it to row 2. Oh, I'm sorry. 0, row 3 and row 2, this would be 7. Okay, now what is great about this is basically this is our row echelon form. What's really nice here is if you think about it, this is our x column, our y column, and our z column. So this means that x equals -2, y equals 7, and z equals 3. Okay, so you can just find that very quickly by doing that. Okay. Now you can also do this in your calculator. Okay, so what I'm going to do is I'm going to go all the way back to my very first equation here where we were asked to find row echelon form. Okay, and what we can do here is we can just write our augmented matrices in here into our calculator. So I have something else in here, so I'm going to change this out. Oops, it's 3 by 4. Okay, so I'm just going to enter in my matrices here. 1, okay, so once you have your matrices in here, what you can do is you can go ahead, and I've stored this as matrix A. So you can go to second matrix, go over to the math, and go all the way down to where it says RREF. It's letter B. Hit enter, and then we want to do this for matrix A. And what's going to happen is you're going to get the same exact matrices we had here. So our x is -2, our y is 7, and our z is 3. Okay, obviously the calculator is a lot faster at doing that than it took us to do that. Okay? All right, the last thing that we're going to go through is solving systems with inverses. Okay, so let's say that we have this new system here, and this should be a review from Algebra 2 really quickly. So what we're going to do is we are going to rewrite this system with matrices. So we're going to let kind of this part represent matrix A. So we're going to take just the coefficients and let this be matrix A. So we have 3, -3, and 6. We have 1, -3, and 10. And then we have -1, 3, and -5. Okay, and then our x matrices is going to be x, y, and z. Okay, so basically if I took A times X, I'm going to get this. And then we'll make our answers be matrix B, which is 20, 40, and 3. Okay, so if I wanted to rewrite this, I would have A times X equals B. This is going to give me the same system that I have up here. Okay, now to solve this system using inverses, what we can do is we can take x equals A inverse times B. Okay, so what we need to do is we need to store in our calculator matrix A and matrix B. So I'm just going to go in and edit this real quick. Oops. Okay, so in our calculators, what we can do is we can do A, matrix A, the inverse key, times matrix B. And what that gives us is this solution matrices, which is our x matrices. So in this case, it's telling us that x equals 7.2, 17.733, and 8.6. Okay, so if we wanted to write our solution as an ordered pair, our x term would be 7.2, our y is 17.733, and our z is 8.6. Okay.